let me tell you 3 personal stories on how startups are bringing university to market. And when I say university, CMC Microsystems has a huge part into that, because if the university didn't have CMC Microsystems, I don't think any of what you're going to see and hear about today would have happened. And I think that's important. I know Oleg did a little bit of a pitch earlier, but I do want to make that clear. A CMC Microsystem is a gem to our research community, especially if you're doing microsystems, microelectronics. And I, for one, I'm a strong supporter, and I think it's the envy of a lot of other countries in the world. So well done, CMC. So let me jump in. So my goal, I guess, in my research is really to go from microelectronics to integrated systems. I like to, a lot of people have asked, what does that mean with regards to microelectronics? Well, you're familiar with Moore's law. I mean, all the people probably on this have seen Moore's law, where we push CMOS electronics down to 5 nanometers and beyond nowadays. Obviously, it's great for digital, but for analog, for radio frequency circuits, for sensors, it's not that much of an excitement, this axis. What's more of an excitement, I would say, is where we're seeing a lot of heterogeneous integration, and more than just digital on ASICs. Okay, mixed signal, of course, RF. This is kind of I would say mixed signal and RF were the canaries in the mine when it comes to doing more with CMOS than digital. Obviously, these two fields are quite mature now when it comes to integrating on CMOS. But now we have MEMS, where we're trying to push the mass production of microelectromechanical systems. They're relatively, I would say, mature in a lot of fields. I'll talk a little bit about that. Photonics, I would say, is next. Clearly, silicon photonics, integrated photonics is a huge business to come. If you want to do a startup, I recommend it. Definitely, you're going to have funding opportunity. I think a lot of people excited in the integration of photonics, which frankly is going to probably be in a similar type of story as what happened with CMOS, 50 or so years ago. So the stories I'll tell you about today will be touching RF, will be touching MEMS, and will be touching photonics. And these 3 will touch 3 different startups, which I'm involved with, not as CTO of all 3, obviously, but I do want to show you how I got involved with these startups, because for many of you, you're students and you have probably great ideas and you want to know, how do I do a startup, or do I want to do a startup? And of course, MEMS is close to my heart. I would say it's one of my big research push, and I always like to say MEMS is a very, I'd say, lucrative field, and it's more and more penetrating the market. And 2 of the 3 stories I'll talk to you about today could be characterized somewhat in that market, which is clearly an expanding market. Now, one thing is interesting. The pandemic has really boosted the appetite for CMOS. Not exactly clear why. I'm sure some analysts will be able to do a more thorough analysis than I. But there was a stagnation in electronics, classical electronics in last 5 years, and now we're seeing a demand like none in the last decade, if not more. And I know this because of talking to a lot of foundries and semiconductor companies. The demand for electronics has never been stronger. Now, your guess is as good as mine as to why. Many believe it's due to the pandemic, but I will not be the one giving you the exact reason, because I wouldn't know. So I would say, if you're interested in what CMC Microsystems is doing, which is basically most of this plot, if not all, well, I think you're in the right field, because economics and so forth are definitely positive. So obviously, when I used to be a young student, CMC was called CMC Electronics, I think. And then, and actually it was called Canadian Microelectronics Corporation. That's what CMC used to stand for. And then people understood that electronics are only part of these. This is an old phone, but even then, electronics are only part of it. And then you have all these sensors, these gyros, these magnetometers, these cameras, at the time, even humidity sensors, microphones, etc. And CMC then rebranded, I think, more than 20 years ago, I think. Oleg will know better, but then became CMC Microsystems, because our business is of innovation is more than just transistors. It's sensors, it's microfluidics, it's photonics, and I think it's quite exciting in the field. So if I go to my interests, and then we'll get to the entrepreneurial stories, I like to touch at the device level. I think of myself as a grounds up person, except I don't go in semiconductor physics. I do mostly circuit level and device level implementations that and hopefully lead to innovation. And I like to integrate stuff together in order to get systems. That's kind of where I stand. And you'll see a little bit of this in the 3 stories we'll talk about today. So today's talk is really, and it took me a while to come up with how I wanted to present this, but I decanted this into 3 stories of how startups are bringing university research to market. I don't pretend to have the truth. I don't pretend to be an expert, but I can at least say that I saw 3 distinct success stories that completely are different from each other in the way that they emerged from the university. So I do want to share that, and maybe one of these 3 you'll associate with, whether it's on the topic, because there are 3 different research topics, but are also 3 different modalities as to how they became startups. So one of them is called MEMS Vision. I guess we won't guess what that one's about since MEMS is in the name. The other is EPonics, which is more related to photonics, and it's a very successful startup in Montreal. And finally, the startup I co-founded called Spark Microsystems, which is more of an RF microelectronics startup. So let's first start with MEMS Vision. This is a Montreal startup that's doing very well. It has a product that's it's a humidity and temperature sensor, and they're expanding beyond that. So let me count you a little bit how this scenario went. So when I was a PhD student, I won't say how long, but it's starting to be quite a while ago, more than a decade and a half, if not more than that. I stopped counting now, sadly, for my own age. But I can say that I was pushed by my supervisors to patent. And this was something I didn't understand at the time. And I wish I understood better at the time, and it was key in order to create a startup. I would say if you want to create a technology startup and you're not going to be based on patents, you have an uphill battle. For software startups, I think it's different, because I know software IP is very different than kind of hardware IP when it comes to protection. I'm not an expert, but if you are going to do innovation in circuits or MEMS or photonics, I think patents are key. So if you're currently doing a PhD or master's, or you're a faculty, I think patents are key. Now, the problem with the patents is they take time, and you have to file them before you publish. So obviously, your students, you want to publish or perish. There's an application called Publish and Perish. I encourage you to check out if you want to stress yourself out a little bit. But you want to publish, and patents typically will delay that because if you do a public disclosure, and by the way, publish means going to Texpo. If you go to Texpo, you've published your work, and it's now a public disclosure, and technically you cannot patent. One thing to note is this isn't true for the US. My understanding, and I'm no patent agent, but I've done this a few times, is that if you do disclose at Texpo, if you do disclose at a conference, if you do disclose in a journal, the US will give you a 1-year period where you can still patent. Unfortunately, that's not the case in other countries, at least the majority of other countries. The good news is if you want to make a startup, you want your patent to be in the US, at least. So it's a minimum. If you're not patented in the US, people will say, well, somebody will rip you off and sell in the US and eclipse you. So I would say if you just heard me say that, and some of you are in your mind freaking out because you just realized that you presented your work last week in a seminar that was public and you really wanted to patent it, well, no worries. As long as you didn't do this more than a year ago, you could still file a patent in the United States. So, and I strongly recommend it if you're willing. We can talk about patents a bit if you have questions. So then my supervisor at the time, who was Mourad El Gamal from McGill University, decided to spin out this startup and found it, called MEMS Vision. Grad students created the logo. It's an engineering logo where, for those that are curious, here's a MOSFET transistor connected to a MEMS resonator device. Fun logo, very engineering, maybe not a marketing logo, but nonetheless, to this day, is still the same logo. And that became now a spin out, which is kind of the jargon for startup that comes out of a university. We have amazing universities in Canada that do spin outs. Some do it better than others. I think ETS does it well. They've had a very good track record. It's not very public, but they do have a lot of startups that came out that were linked to the ATS ecosystem. And I think many other universities do a very good job as well. So I'm pretty sure if you're in a Canadian university, either in Quebec or anywhere else in Canada, you have a very good chance of having the tools required to spin out a company if you feel that's what you want to do. Now, what's important to note is when you're going to want to start a company, the first thing the university will say is we have an IP policy. Some universities, very few universities, will say you own all of the IP, go in peace, and that's it, you're done. Many universities will say, well, we are going to own half of the intellectual properties, meaning typically the patent, and you will have to negotiate. They will own the IP, and they will say we want to get 50% of the revenue this IP does. So the university owns the IP, they get 50%, let's say, of the royalties. But then the problem with that, it doesn't seem that bad, because I'll be honest with you. Another thing I will tell you later is don't worry about how much percent you're giving away, okay? When you start a company, don't worry about that. It's not gonna matter, and I'll talk to you engineering-wise later and you'll see why. So, but then you'll say, okay, no big deal. I have to give a few percent of royalties to the university when I start to sell my product with the patent. The problem is a lot of university will take immense amount of time to negotiate this. It could take a year easily if you don't do this right. And some universities will have bad terms that are not going to help you fund your company, because we'll talk about how to fund the company a little bit in these stories. So this is an important thing, and I would say do it earlier than later, okay? So that you cannot basically create a company if you don't have a license to your patent. Even though you created the patent, chances are the university owns it and you need to license it. So of course at McGill, that's what happened. And this startup had to license the technology and then be able to operate. This startup wanted to fund itself, and it did it with what we call the concept of bootstrapping, meaning self-fund, figure out a way to get contracts, to push revenue, and get to the product. This is a slower way than the other way I'll talk about later, but it's a way where you get to keep a lot of your ownership. So if the company is a pie, well, you end up still owning most of that pie since you didn't take venture capital money. You may have given some of that pie away, perhaps, to have people join the company, to help you work on it. But typically, if you don't take venture capital, you will have more ownership. But you will technically go slow, because in hardware and electronics, you need to burn a lot of money. There's no way around it. If you want to make a product, you'll need to burn money. So now, I do want to tell you, though, that it is possible to bootstrap a hardware startup. MEMS Vision has proved that it's possible. They're operating. They're very successful now. And they, to my knowledge, they are still in a mode where they're using more of a bootstrapping mode. So they're an extremely successful story there, and to get to a product. So I think this story for MEMS Vision, what I want you to get out of it is if you're doing grad studies and you really think your grad studies are worth going for a startup, well, make sure you protect your technology and your ideas, which means you may have to publish at a different calendar that you would have ordinarily. You'll have to discuss this with your supervisor, obviously, because he or she may have their own idea on how or if they want a patent. But fundamentally, depending on who the inventors are, this is a collective decision the inventors have to take. So if I continue, and essentially bootstrapping is like this, okay? You're pushing the rock up, and it's a painful, it's a long process, but it can be done, and it can be done successfully. Many software startups do this because software inherently is not as costly, especially if you have employees that are willing to work for shares. They don't need cash to live, or they live with their parents. I mean, we've heard a lot of stories about that in the past. But it is a slow and route. So there's other methods as well. And customers are absolutely necessary. If you're going to think you're going to bootstrap a company without customers that are willing to pay to help you to get there, I think this is now a dream that won't come true, because at some point somebody's got to be willing to invest some money for you to build your prototypes. Now, luckily, you have CMC, who has relatively low-cost prototyping capability. And I urge you to do as much prototyping while you're at PhD, because in the case of, of obviously my PhD, where we did some innovation that was patented, a lot of it was at the time made possible via the association with CMC because of CAD access and because of course, technology access. And of course, we all know that's a lot less expensive to do here than it is to do here because of the university, advantages on cost. So essentially, the vision of this startup was to take MEMS and take CMOS and put them together into one device. And there's a lot of difficulties doing that due to the thermal limits between CMOS and MEMS. Typically, it's very hard to grow a MEMS on a CMOS and keep the CMOS alive. And that was the main, I guess, innovation in that IP, was that it allowed to provide post CMOS, above CMOS MEMS devices, and that's how that company had its unique capabilities, and that's how they were able to this day still be differentiated. And these are some nice pictures that were published a while back now. This is getting old since it was my PhD, but you can see a few devices where we have some MEMS switches, some MEMS resonators, some diaphragm that could be used for ultrasonics that are integrated above a silicon chip. And of course, this is an idea of this is the results of a humidity sensor that was built above a chip to show that before and after processing the MEMS, the device was still basically pretty much the same. So that was an important realization for that particular IP. So that is the company. It has now its series of sensors, and you can go to their website if you're curious. They have a lot of stuff, and they're operating in Montreal and have customers all over the world. So it's really exciting to see that story. And I think the company is now at least 10 years old. From my memory. So that's a good story. Heponics is a startup that I did not start, that I'm not involved in, but that I had the pleasure of being introduced to by a colleague who met them in a networking event. And at the time, the startup was very small, handful of people, and they had a product which, to what I understood, wasn't really doing it for them in their market. And we had a technology, this colleague and I, Professor Menard at UQAM, that was aimed to combine MEMS devices with integrated waveguides, photonic waveguides. So obviously you can imagine putting MEMS photonics. Professor Menard is an expert in photonics. I'm an expert in MEMS. So we kind of melded our expertise, and they saw potential, and they did a few grants. So I'll go to the story. So we had patents. So me and Professor Menard, maybe it was because of my prior experience, I had been taught, quote unquote, that if you have something you think will have some commercial value, patent it. Maybe you don't know why you're going to patent it, but if your university is willing to go for it, go for it. So we had patented a few key ideas in a patent, or I think it was a handful, 2 patents or 1, I forget. And then we met this company. We did a few NSERC Engage grants, which don't exist anymore, but there's a similar program where you get a bit of money from NSERC to do some research with a startup or a company, or a small company, or even a big company. And we then negotiated a license with this startup. I am not in the startup at all, but I was a professor that licensed to that startup the technology. The university took care of that, right? The professor is typically not involved in license discussions. And then we did an NSERC CRD grant, which ended, and we did another one. So that startup basically uses the university as part of its R&D arm. It's now, I think, 5th or 6th year that we're collaborating with them. And they raised a seed VC round. So they used venture capital, and they raised a Series A round, and I'm sure they'll raise more money. I think the company now is getting pretty big. But you can see here that the startup came from outside and interfaced with us professors. However, there was still a common denominator, is there was a patent. Okay. And I would say you will have professors that have companies come to them to work on a project without a patent. But typically, since this is about entrepreneurship, I don't think it would be startups, because typically startups would either have their own patent in the startup, and they would bring a professor in to help on the research front, or the patent is at the university, the startup sees it, captures it, licenses it, and moves on. And there's a lot of models like this. Some startups will just license the IP and then go away. They'll never talk to the university again. Okay, for example, this happens in a lot of startups where the model is, let's find a good IP somewhere in the university all over the world, let's license it and make a startup. I know that Tandem Launch, for example, in Montreal has done some of that, where they try to cherry pick key IP that they can license to build startups with smart people. And it's a great incubator in Montreal. So that's a story. And the company now still needed customers. So that's the other common denominator. They had strong customers, and that's how they were able to lift this company to the next level. So my other message is, you will need customers. You will need customers. I cannot say that more than enough. And I know PhDs, masters, even bachelor's engineers, we're not thinking customers, we're thinking technology, my innovation. These are all great, but if you don't have the customers, and I didn't know this before, I'm saying this after the fact of seeing all this, if you don't have a customer that's willing to pay something or write something very convincing of support for you, I don't think you're going to advance. And of course, a venture capitalist is kind of a light speed, right? They will pump money into your startup and they will make you go much faster. And I saw both. I saw the Bootstrapped, I saw the VC, and I can tell you for a fact you'll go much faster. But you will have, quote unquote, investors, right? That you want to please. So whether we like it or not, when we take external money, the company is not just ours anymore, and that's okay. Remember what I said. Don't worry about owning all of the pie. I'm telling you, don't worry about giving percent to the university. Don't worry about giving shares to a friend who wants to work for free. Don't worry about giving money to a percent to an investor. Obviously, it has to be reasonable, but don't worry too much about that. And at the end of the day, if the company fails, and it doesn't matter if you have 100% of $0. But if you have 1%, of $1 billion, it's a reasonable amount. Obviously, you want more than 1%, but if you founded the company, I'm sure you can end up much higher than 1%. And if you're a strong success, I don't think you'll worry that you have X percent versus X minus Y percent. Okay, the percentage points are really important when we think about them, but in reality, when you don't think about it and you just be really mathematical and you start doing models, and we're engineers, we go in Excel and we go read about how these dilution works, and you do model, you realize, wow, okay, whether I have 15% or 12% at the end, it doesn't make a big difference. Whereas that 3% I gave away to a key person that came to work for free or came to work at 1/3 the salary and made my company generate revenue faster, well, that probably ended up making my 12% worth way more than the 15% if I didn't hire that person. So it's all about value creation. Okay, so don't worry about VCs. They're there to help. They'll take a lot of money. They'll take a lot of percent. Trust me, you're gonna be quite troubled by how much percent they'll take. And if you have questions, we could discuss that later. But if you're successful, it's about creating value faster, as fast as possible. That's the key. You want your percents to be worth more money fast. It's not about owning more percent to get more money. It's about making every percent you own worth the most money possible. That is how you decide what to give money away, percents away of ownership, okay? So Heponics in their case, just to be a bit scientific, they have these MEMS devices. There's waveguides on top. This is a picture. I think this is moving here. So you can make this rotate. The light comes in. This is a mirror. The light gets reflected. Obviously, the mirror turns, so the light as it reflects will move, will deflect in different angles. And you can do this in a very integrated fashion thanks to MEMS. I think that's about 200-300 micrometers just for scale's sake. So this is a device that we published a while ago already, which is essentially a switch where you have this rotational MEMS, you have the waveguides that are integrated. At the time when this was done, nobody really had that kind of capability, and it took a lot of effort in university fabs. We used McGill fab, Polytechnique fab, UQAM fab, ETS fab, INRS fab, every fab at Montreal ecosystem to make this happen. I don't know of any project that was so intensively using microfabs in Montreal area at the time, and we got something unique, and we were able to basically steer the light in a, as you can see here, you know, the mirror turns and steer the light. Now this is unique because you now have a chip that has the light. The light is not in free space, and obviously you can do a lot of cool stuff with this, and this is where Eponics is continuing to innovate, and they have stuff that's way more advanced than this now. But again, that's their license, that's their research. It's on their side, and we're continuing on the research side to produce stuff, and we are still publishing. One thing Eponics understands is once the patent is there, you're protected. You can publish. Be careful. You don't want to publish necessarily all the secrets, but publishing is great for a tech company to gain renown. But that's after, of course, you've got your patents covered and granted and so forth. So the last topic, which I have about 15 minutes for, which is the one that's obviously taking a lot of my time now, is Spark Microsystems, which is a company that, so I saw Eponics, I saw MEMS Vision, and I figured, okay, we got to do this on our own now. And I like to work in collaboration. So I have a partner called Prof. Dominique Delambre. He's more of a microwave antenna guru specialist. I'm more on the RFIC front. And we joined forces and we did a lot of research starting in 2009. We had a few masters, a postdoc and so forth, got some money from NSERC. And again, my reflex of patenting came. So I said, okay, you know, I think this could be commercial one day. Let us patent it, obviously. And then we thought it was so good that let us not even publish anything, because now, well, I told you it's good to publish after patenting, which is fine. If you want to boost your CV, publish after patent, you're protected. You don't want to tip off the competition or give away your secrets, even though they're patented. So we decided not to publish anything. So if you look at my CV and try to look at publication in ultra-wideband radio frequency circuits, you'll see a bit of stuff early and then it completely stopped as if it was a complete failure in the research. But then, of course, in parallel, this company was being built. So this one is a little bit more complex, but I'll go through it. So obviously, you're a professor, you're very busy, but nonetheless, you patent this. We started with bootstrapped research, meaning that no funding agency wanted to fund this. We tried a few times. I mean, professors in the chat will know sometimes you fail. You do a grant proposal, no matter how much you think it's good, it doesn't get through. We even had the reviewers say, oh, this is backward technology, it'll never have any impact. So I'm happy we proved them wrong at this point, but nonetheless, it didn't work. We patented nonetheless, we patented a bit more. So we patented at first, we patented after. Then luckily we were able to get a grant from the provincial and federal governments. We had results. One thing I will say, that's where CMC is pivotal. CMC allowed us to get results with peanuts because we could build a chip to demonstrate our concept. If CMC didn't exist, this idea would have died probably right here. Maybe we would have patented it because you don't necessarily need to prove it works to patent. That's a long story, but it's true. You need to teach how to do it, but I would say you should have it work before you patent. So we would probably die here, and that would be it. So thanks to CMC, thanks to a bit of funding, we're able to patent a bit more, patents. I think it's a good 13, 15 patents now that were licensed. So again, we spun out, we licensed the technology. This time it was us. I was involved personally in it because obviously now I decided to take the plunge in the startup. We talked to the university. We went into the Centec incubator. Centec incubator is an incubator that takes projects from any university, anywhere, as long as it's hardware related. And they are linked to ETS, but they take, they have startups from McGill, they have startups from even, I remember from Washington at the time when I was there. And me and my colleague did the whole program, even though, yes, we were professors, but ETS allowed us to do this and to do it. And again, we transparently mentioned it and we did the whole program. And I'm very glad we did this incubator program. And that's my other point is when you're a PhD or a master's or an engineer, you're not technically a business person and you don't really know how to succeed a startup. Okay, I'll be very honest and very candid about that. And I talk about myself here, not just the world. You're trained to do research, to be scientific, to be rational, to be extremely good at technical analysis, at writing strong reports, but you're not necessarily, and you're taught to innovate, but you're not taught to bring a technology to market. You're not taught that customers are your blood and their life and blood if you want to do a startup. And you believe you need to start selling when everything is finished, okay? Because you publish stuff when the work is finished, right? That's at least how I've been brought up. When you do a project, you publish when you have the results and everything is there. The graphs are good, the error bars make sense, and you don't preliminarily publish. Typically, you publish sometimes in conferences and stuff, but the journal typically it's cooked up, it's ready. But when you do a company, you got to start selling a lot earlier. And that incubator showed us what not to do, what to do. And in 2016, this company was incorporated as Spark Microsystems. The reason for the word Spark is because the first radio developed by, some would say Marconi, some would disagree, but was a spark gap radio, which used sparks in the air to communicate wirelessly. Obviously, they were relegated to standard FM radio and AM radio, and now the radios you guys know and cell phones and stuff. But the impulse nature of communicating with sparks turns out can make very unique capabilities happen. And that's why we call the company Spark Microsystems, because it's an impulse radio. It doesn't make sparks anymore, but it does use impulses to communicate. So we funded the company. We then did Series A, and I would say if you go to an incubator just to get educated on how VCs work and how you can get a VC term sheet and how you can negotiate a term sheet to get funded, to get good amounts of money into your startup without getting taken advantage of. Because I said percentage don't matter. That doesn't mean you should get taken advantage of either, right? So it's just got to make sense. So these things are not something you learn as a PhD, as a postdoc, as a bachelor's of engineering, or as a professor, frankly. And I think these were key. And the company now is a product that is shipping, and essentially, again, we went to ludicrous speed with the money, and it takes millions of dollars, and that's when you realize research is cheap in university. When you get out of university, it's expensive. So my advice here is try to keep your research in the university as long as possible, especially if you can leverage CMC Microsystems. It will make your job a lot easier to raise money later. Venture capitalists want to see stuff working before they put money. Venture capitalist wants to see customer traction before they put money. So you see now you need CMC Microsystems and your university relationship to hopefully get something working enough on the table so that your venture capitalist says, I think this can work. But you need more than that. You need to have done selling and try to get customers that want to see what you made become a product, and not just want to see it verbally, but are willing to write a letter or call an investor without you on the line to tell them that they want to see this happen because they would buy it when it's finished. So that's what we've learned. And I encourage you all, if you want to do a startup, to first, of course, figure out what you want to do, but try to go into an incubator. I will clearly say Centec, but there's also EcoFuel, which we did, which is excellent too if you're a clean tech fund. You're a clean tech startup. There's Founder Fuel in Montreal. I can only speak for Montreal, but I know all over Canada, there's a lot of great incubators out there, and leverage at least one. And I would say the more the merrier if you have the time. They cannot be understated in your success path. So of course, all this sweat and this sweat and pain just to make a chip that's 4 millimeters and that's selling, in different markets. It's a pride, of course. When we're in research, we never get to that final point. Research is we always give a preview, but we never make it to a product. So to me, it was very great to really go to the end of a project. Say, okay, we're going to go from product for a white sheet of paper, and we're going to go all the way to the end to a product. And that was a humbling experience, to tell you the truth, but also I think an experience that I recommend anyone who wants to do a startup do. It's something else. So I will skip this, time is running. So I will finish with some tips, and I know we're running 5 minutes now, so I'll try to be, so don't create a problem, create a solution. So when we do a PhD or any research, you don't necessarily need to create a problem, but often you need to express what we call the problem statement. What are you trying to solve? So sometimes when I see people think about startups, they want to create a problem to solve. I would say you want to solve a solution to a problem, and a problem that enough people have. So that's the first thing. So hopefully all of you that think about doing a startup will think about your PhD, say, okay, am I creating a solution here to something that needs to be solved? Okay, now it's okay. You can do a PhD that's amazing without really solving a problem that is going to be interesting to customers. That is completely valid, because nothing in a PhD says that your solution has to be commercially viable. Okay. However, if you want to do a startup, your solution to a given problem must be commercially viable. And I would say the top priority before you quit your job or you start burning 50 hours a week on your startup or 70 hours a week on your startup is make sure that your solution has a market and people want it. There's no science how you do that. You got to talk to people. You got to investigate, do market studies, things like that. Make sure you get your patent if you can. And that can be very cheap. You can write it yourself and do what we call a provisional. I don't recommend it, but if it's that or nothing, at least file what you can. The patent's a must. If you don't have the patent, I don't think you'll go very far when it comes to hardware startup. Negotiate with your university tech transfer early on, so that you can have your license. It's easier to negotiate before your technology is worth anything. Okay, it's human nature. If you go and negotiate after a company worth $1 trillion wants to buy your startup, it's human nature. I'm sure the university will be more, interested, let me say that, on the terms of the license than if you just negotiate now, where you're, at your garage with your parents and nobody seems to want this technology, and it's just normal. And that's something I encourage you to do. Try to become a salesperson as soon as you can. And if you're not a good salesperson, get a partner who's good at selling. With your research. And I would say, even if you never do a startup, make sure that you know how to sell your research, because whether you like it or not, when you do a PhD defense or any type of defense, whether it's master's, there's a sales job there. You need to sell that what you did is good, and that's selling, not just science. Start selling early. Okay, as soon as you have the hint of a prototype or the hint of a concept that can be simulated, try to see if you get customer traction. Try to make sure you're protected. And if you're not protected with a patent, then make sure you don't give them special sauce, because that could be a problem. Don't underestimate the power of your network. A network is extremely important. I'm not talking about computer network here. I'm talking about a human network. So LinkedIn, all this stuff. It's very important, because sometimes, because you know a person who knows another person, you'll get something pivotal into your roadmap. So it's important. Don't focus only on the large companies. Sometimes large companies are better left for a bit later, when your startup will be more mature and large enough to handle the amount of firepower a large company can bring onto your startup in questioning and in due diligence. Try to find business savvy people. You may be lucky to be a wonderful scientist and a great business person, but the odds are also that you may not. Don't be afraid of linking up with a business person. It's, engineers sometimes, when we start our careers, oh yeah, business, easy. It's not. There's a skill there. So if you don't know it, don't worry. These people should come, and yeah, they will take percentages away from the pie, but you know what? That's what it is. You need business people as well to make this success. And there's no universal there's no universal path. I showed you 3 that are very different, but I'm sure there's thousands more paths that I didn't think of here. So to conclude, so the overall story that I told you today in very informal terms is I saw 3 startups over, that's out of date, should say 10 years, I guess. These startups employ now probably 75 plus, maybe 100 employees, a lot of funding, unique technologies that solve problems in all 3 cases, created by 24 issued patents, all of these in university. So patenting is, and by the way, this will help your CV, whether we like it or not. An issued patent will look good on your CV. It's not, may not be as good as a Nature paper, but clearly has an impact. So don't worry about patenting. And of course, the publication you can do. You can still publish. It's not because you patent you don't publish. You may not want to publish though at some point, and I made that choice for some projects. And work resilience. But if you are doing grad studies, you already probably have the resilience part and the work part. I'm not worried. Typically, these are hard projects. And yeah, dreams. You got to do this for the potential, because at the end of the day, there will be hard times. And if you're only doing this for the money, I don't think that will get you through to the end. So thank you very much. I know we're right on time. I don't know if we have a minute or 2 on questions, but I'll stop here.